Let's record this lesson here. I don't need to repeat. So let's start from sketching of linear graphs. Huh? Then we'll look at sketching of quadratic graphs. Sketching of linear graphs. Sketching of linear graphs. Because sometimes they give you a linear graph and they say find the equation. No? You get my point. Mm-hmm. Or sometimes they draw a line. So we know that a linear graph is the line y is equal to mx plus c, huh? Where c is the y-intercept. I'm sure you know that. Huh? So if I'm given an equation like this, y is equal to 2x. Y is equal to 2x, and I want to sketch it. Straight away, I know that my c is 0 because there is no c here. So it means such a line will cut at the what? At the origin. Because when x is 0, y is 0. Clear? Mm-hmm. So that's my first point straight away. Because on a line, all you need is 2 points. Then you can use any point. For example, when x is 2 here, y will be 2 by 2. Yes, y will be 4. Like this. So you show that doesn't have to be perfect. You're simply showing them that you know that is 2, 4, like this. Then you use your ruler to plot. That's the sketch of the line y is equal to 2x. Clear?
Yes.
Now, having said that, let's look at a different line now where we have a value of c. So if I have y is equal to minus 2x plus 1. Y is equal to minus 2x plus 1. Now, the first thing that I know about this graph is that my c value is 1. Huh? So it means that equation cuts the y-axis at 1. When x is equal to 0, y is 1. That's our first point. Clear now?
Yes.
Then you pick any point that you want to. For example, if I had picked, let's say 3 as an example here. When x is equal to 3, let's go and substitute 3. Hold on. Still here. Hi. I'm gonna feel some Lawrence. Hi, how are you? Hi. 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 Oh, sorry about that. So now, when x is equal to minus 2, so y, what did you find the value? I'm sure you're finding that out. Mm-hmm. Plus 1. What did you get? Minus 5. Mm. So now minus 5, maybe somewhere you're just using something that makes sense. It doesn't have, you don't have to measure anything there. Clear? They're interested in seeing this. 3 minus 5, 1. So you see your line is like that, which is correct. There was a negative gradient. Negative gradient is like this. So y is equal to minus 2x plus 1. Clear?
Yes.
Okay. Clear? It seems the volume is...
Yes.
Okay. I think I can hear you better now. Now, let's say we have 2y is equal to 3x plus 1, like this. So what is the first thing that we should do if you want to sketch such a curve? Now it's different from the ones that I've given. Your volume now. Can you hear me? Your volume seems to be...
You have to make y subject of the formula.
You saying? We must make the coefficient of y 1. Yes. Make the coefficient of y. So divide by 2. So that y is equal to 3x over 2 plus half. Clear now? So now it means that line that we want to draw cuts the y at what? At half. Clear now? That's where it cuts. Then now, I can look for any value here. From this, I know that if I'm going to put 1 here, it's going to make it easy. So if x is equal to 1 here, 1, that would be 3.5 plus half. So what is that? It's 4 over 2, which is 2. So 1, maybe 2 there. Clear?
Yes.
Then I have my sketch. Make sense?
Yeah.
Sketching of linear graphs is the easiest. What they can also do now in the exams, I think that was in the June exam, they give you, in the paper too, they give you something like this. Like this, clear. And they find the equations of the line.
Yes. So you say y is equal to mx.
Clear? Now, equation of the first line, what do? We can tell that because it's cutting at 4, it's y is equal to mx plus what?
4.
Plus 4. So is this y is equal to mx plus 6. Now we need to find the gradient. But what points are we given? We are given the point 0, 4, the first one here. And this point is 3 what? 3 is 0. Are we agree? So change in y is equal to 4 minus 0 over 0 minus 3. In top, so we get negative 4 over 3. Well, this gives me minus 3. This gives you 4. Clear? So it means y is equal to minus 4 over 3 x plus 4. Done. Now, to do this, we are given this point. So we are given sorry, 0, 6. And what's the other point? Negative 2, 0. Clear now. So the gradient 6 minus 0 over 0 minus minus 2 will give us 6 over negative. Negative is positive. Then we get 3. Make sense?
Yes.
So it means y is equal to 3x plus 6. Done. Sorry. Okay. Are we together? Makes sense now?
Yes.
Now let's look at, so it now makes sense. You should be able to plot any line. Remember, we simply said a line that is y is equal to mx like this always cuts at the origin. Clear?
Yes.
Then the other lines that we were doing, remember when we were doing inequalities, which are straight lines, which do not obey this y is equal, is, for example, if I say y is equal to 5. I'm sure you know that. It's simply when the value of y is always equal to 5. Clear now? Like this. then x is equal to 5 is this line here. Make sense?
Yes.
Which means the origin, the x-axis is actually the line y is equal to 0. Clear?
Yes.
And this y-axis, what's not changing is the x value, which is always 0. It's actually x is equal to 0. Make sense?
Yes.
So now let's look at quadratic graphs. No, before we look at quadratic, I saw that there's something that I need to mention here on these lines here. Sorry about that. If I have this line here, you know this, f of x is equal to 1 over x like this. Now, there's something about this line. What happens if you type in a calculator 1 divided by 0? Gives you an error. So it means such a graph has got an asymptote, where because we're saying x is not equal to what? X should never be equal to 0. So what it means graphically is that this graph can never touch what? The y-axis. The line x is equal to 0. Clear? So it will be like this. It's symmetrical. Okay, it will be like this altogether. It comes very close the other side, comes very close there, comes very close there. Clear now? That's how the graph looks like. Making sense?
Yeah.
Now, what happens now if I say f of x is actually a transformation is equal to 1 over x plus 1. But this is a plus 1. So think of this. Remember we said something you know. So if I think of x plus 1 is equal to 0 at the bottom here, it means x should never be equal to minus 1. Because if x is equal to minus 1 here, I'm going to have 1 over 0. That's what I want to avoid. Can you see that?
Yes.
But graphically, do you know what has happened? We have transformed this graph. We have moved it. We have shifted it by 1 unit. Clear? Such that the asymptote now is now on this. Instead of this, it's now on the line x is equal to minus 1.
1.
Clear? So it's now like this. Making sense?
Yes, it is.
So if we do the opposites, if we have a negative, here. I hope I'm recording this. Yep. So if we have a negative, okay, so if we have f of x here being equal to 1 over, let's say now, let's say it's a negative now. What's happening? If I have x here minus 2 like this. So think of this. Remember, if I think of x minus 2, so x minus 2 is equal to 0 at the bottom, it means x is equal to 2. So this should never be x is equal to 2. because there, when I do that, I will have 1 over 0. Clear now? So I'm sure you are seeing how the graph of 1 over x has been shifted. It has been shifted. If it's a negative, now we shifted 2 units to the what? To the right there. Clear? Because x is equal to, x should not be equal to 2. Make sense?
Yes.
Like that. Clear?
Yes.
Okay. So now, that's the f of x there. Now let's look at quadratic. Quadratic graphs. What am I even thinking? Quadratic graphs. Now a quadratic graph always forms a parabola. I'm sure you know that. Huh? A parabola. Huh? So the first easiest graph is the graph of y, or f of x is equal to x squared. Huh? This graph is very easy. Huh? I'm sure you have done that at school a lot. 0, 0, 0. If I do 1 here, it will be 2. If I do 2 here, it will be 4. Squaring, huh? Squaring like this. So it's something like this. It's symmetrical about this point. Huh? Y is equal to x squared. Clear?
Yes.
Y is equal to x squared. So all your transformations are to do with this. Comes from this here. I'll show you now. Give me any quadratic equation, I'll prove to you. So for example, if I have f of x is equal to x squared minus, let's say minus 2x plus 1 like this. Clear now? Let's complete the square. So the easiest thing to do when you're sketching, you complete the square. Clear? You complete this.
All of it.
Yes, if you're given any quadratic graph, if you want to sketch it, you always complete the square. It makes things easy. So now look at this. Because we want to compare it with the graph that I've said, this one. So now let's complete the square there. This is 1, it's fine. So divide this by 2, you know that. Huh? So it's x, if you divide by 2, it's minus 1, huh? Minus 1 like this squared. Then plus 1, yes, you subtract the square of this, which is simply minus what? Minus 1, huh?
3.
Are we agreeing?
Oh, yeah. Oops. I was saying.
Squared, remember? 1 squared is 1 here. So that gives us x minus 1. You should be confident with this. So this is a 0 there. So do you know what it means? I'll show you what it means. The same graph, remember we did the graph of f. Let me put it here. This one. Well, f of y is equal to x squared. Huh? Now, if it's minus 1, I'm simply moving that whole graph 1 unit here. Instead of being this at 0, it's now at 1, like this. Clear?
Is it not supposed to be at minus 1?
Not minus 1. Look at this.
Okay, never mind.
Does that make sense to you then?
Yeah.
Because if it's minus 1, this would be minus 1 squared. It gives you 4. That's not correct, huh? Clear now? But if it's 1, what's 1 minus 1? 0. Squared, 0. See that? I thought you saw that even with the 1 over x there.
Yeah,
When I did y, when I did 1 over x plus 1, it didn't move, it moved it to the left. If it was negative 1, it's actually moving it to the right. I thought you saw that. Clear now? So it moves the whole graph here like this. So that's the graph here. Now let's look at a different one. If I have x squared minus 4x plus 8 like this. Just hold on. I'm there, James. I'm there. And I'm there. I'm there. And over so. Hello, makasih mbak. Ah, right. Kau saya cuma. Right. Aku kan, kau saya cuma. Oh, kau nanya. Wah, ini yang ngaji phone ni nanti saya ni akan deh. Cakap, kau mau aru? Aru, aru bos tu le. Kalau tu phone ni register, very important. What? Saya. Ini. Jangan phone ni ring lesen. Alright. Alright, ini saya nak. I sorry about that. Sorry. I had to attend it. Are you there?
Yes, I am.
So now look at this. You need to be confident. So what do? We check first if this coefficient is 1, clear? Yes. That's the first thing that we always check. So it's 1, it's okay. So we only go to the middle term. What's the coefficient of x here is what? Is minus 4. Then you divide minus 4 divided by 2. I'm sure I've done that in school. It's minus 2. So it's like this, squared. Are we together? Then plus 8, or then you subtract. You take away the square. What's the square of 2 there? It's 4. 2 squared.
What would the coefficient was 5?
Which coefficient?
Of x squared.
This is x squared minus 4. The coefficient here is 1, and I didn't decipher. I simply said x squared.
But what would I do if it was 5x?
I'll explain. Don't worry about it. I'll explain that. Now, okay, are we together there? So now it's x minus 2 squared plus what? Plus 4. Clear? So there are two transformations to our graph of y is equal to x squared. Clear? The first thing is we have moved it. Look at this. I'm sure you can now agree. Because it's negative, we have moved it 2 units to the what? To the right.
To right.
Like this. Then this moves the graph 4 units upwards. From 0, this whole graph moves 4 units upwards. So it's like this. This will be my turning point at 4, 2 there. I hope it's now making sense.
Yes, it is.
Like this. Clear?
Yes.
Making sense?
Yes, it is.
Okay. So such a curve like this does not have a quadratic. If you try to, it will give you an error because it doesn't cut the what? The x-axis. Clear? B squared minus 4ac is less than 0. When b squared minus 4ac is less than 0, it does not have a solution. Clear? Or maybe you don't understand what I mean by b squared minus 4ac. I'm picking it from your quadratic equation. Let me just explain it here. B squared minus 4. I'm picking that part of the quadratic that you say square root. This b squared, if it's less than 0, no solutions.
Yes.
Because now look at this. B squared is what? Is negative 4 squared. Minus 4 multiplied by a is 1, c is 8. So there I get 16 minus 32, which gives me a negative 16. No solutions. How together?
Yes.
If you're trying to solve it, it will give you a negative. You can't find the root of a negative number. Clear?
Yes.
Now, so then let's go back to what you have just said, which is very important. What the question that you have asked now is a key important question here. Now, you asked, what if I have, for example, 3x squared minus 4x plus 5 for argument's sake. I want to draw that. I divide the coefficient of x squared should always be 1. So I divide everything by what? By 3.
Right.
So that I have x squared minus 4 over 3x plus 5 over 3. Then I say now the same thing when I'm completing the square. Coefficient of this is 4 over negative 4 over 3. Then I divide by 2. So what's minus 4 over 3 divided by 2? Can you use your calculator? Minus 4 over 3 divided by 2.
Negative 2 over 3.
Negative 2
over
over 3, correct, like this. Squared, make sense? Plus 5 over 3 minus the square of this. So you can simply square the denominator, which is 4, square the denominator, 9. Clear now? Then it will be x minus 2 over 3 squared. Can you simplify this from the calculator? 5 over 3 minus 4 over 9. What do you get?
11 over 9.
11 over 9. Positive.
Yeah.
So saying plus 11 over 9. So you have an idea. The graph of x squared is moved, because it's negative, it's moved by 2/3. Clear? That's the first thing. By 2/3 like this. Then it's moved up by 11 over what? 11 over 9. Clear now? But which is 1 and something. Hope it's making sense like this.
It is.
If it's negative, we are moving the graph down. Clear?
Down. Yeah.
So it means I should be able to sketch any quadratic equation. Making sense? Any quadratic equation, I should be able to sketch it. So if I have x squared minus 3x minus 10 like this. Now, the other way to sketch, if it's factorizable, like this, it's not necessary to complete. I can complete the square altogether. I'll simply get the same graph. Okay, let me prove. Let me prove you. I want to show you the other method. If we can we factorize this? I'm sure we can factorize it. So it's x minus 5 factor of x plus 2. Do you know what that means? Because remember, if I'm solving this equation, I say x minus 5 is equal to 0. So x is equal to 5. So it means one of your solutions is 5 here, and one of your solutions is negative what? Negative 2. So it's like this. Clear? Make sense? Or let's use the method that we've just done here. It can be used for everything. Now, so there, half of that is x minus 3 over 2 squared minus 10 minus the square of that. What's the square of that? 9 over 4. Clear? So x minus 3 over 2 squared. What is 10 minus 9 over 4?
Negative 49 over 4.
Negative 49 over 4. Okay. So this one actually tells you the turning point. Okay, so we are shifting the graph there to 3 over 2, 1.5. You just need to see something here. Then this one. Minus 5 is going all the way. So, okay, that's fine. To minus 49 over 4. So, unlike the first graph, this one actually tells us the turning point. Clear? Where the graph is actually turning. That one didn't tell us the turning point. But when you complete the square, you actually know the turning point. Which means there it will be just turning at 5 anyway. And the 2 there, I'll prove it to you there, negative 2. Clear then? Let's try to solve it to prove it's true here. 5 minus 3 over 2 squared. What do you get from a calculator? Then minus 49 over 4. Five minus 3 over 2, what do you get? Then you square that.
49 over 4.
Yeah, and if you say 49 over 4 minus 49 over 4 is what? It's 0. Can you see that? Clear now?
Yeah.
Makes sense to you now?
Yes.
So that's all you need to know. You can sketch any quadratic graph. Then the other thing is you need to be able to, but that is in actual drawings. We said, for example, if we have any quadratic graph and we have, for example, if I have f of x is equal to x squared minus 4x plus 12. Then I have the line also y is equal to 2x plus 1. So remember, when we want to solve graphically to find the solution of f of x is equal to 2x plus 1 graphically, normally they give you a graph. You sketch this graph. Then you draw this line on the same grid altogether. The points where the line is intersecting with the graph. Clear? The points where the line is intersecting, this is just an example. I'm saying the points, the x values, clear now, are the solutions for the what?
For the graph.
For that. Clear now? But anyway, we've done that in graphs now. Now let's look at transformations. Sorry, trigonometry. Trig graphs. Trigonometry. Trigonometry, clear?
Yes.
Trig graphs. So now, I'll start with the first one. F of x or y is equal to sine x. Then there are certain things that I need to talk about here. Sine x. So let's do that together. So I want to show you, even if you forget in the exam, use your calculator. I hope you got your calculator there. I'll show you what you do if you forget in an exam there. So this is 0 degrees, 90, you divide it into quadrants. 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Clear now?
Yes.
Now, what sine 0 from your calculator should be 0?
Yes.
What is sine 90?
1.
No, 1. You see? What is sine 180? Should be 0 in a calculator.
Yes.
Sine 270 should be minus 1.
Yes.
And this is like this. So like that. So what it means, how this helps us, is that sine is positive in the first quadrant and sine is positive in the second quadrant. Negative, negative. Clear? So if I was to draw what I'm saying here, first quadrant is always this. So first, second, that's how they are done. Third, and fourth. Clear? So there is positive, there is positive, there is negative, there is negative. Such that now, if I do sine of, look at this, if I do sine 20 like this, 20 degrees, sine 20 degrees, it's equivalent to this, look at this, because it's also positive here, I can draw this like this, and also say 20 degrees here. Clear? Now follow me. Now you move, because you are moving anti-clockwise, you move from this to this. So what is that angle up to that? It's 160. It's 20 degrees minus 180. I hope you are following there. So it means it's also equal to sine what? 160 degrees. Try to prove it from a calculator, you find it right now. Is that making sense?
Yes.
Okay. Now, so if it means if I say sine 40 degrees here, I'm applying the same concept here. 40 degrees here, 40 degrees here. So sine 40 would be equal to sine 180 minus 40. I'm sure you can tell that. Which would be sine what? 140. Clear?
Yes.
Okay. Which means when they give me an equation, for example, an equation like this, 2 sine x is equal to, let me use 3 sine x. There's a reason I'm doing this. It's equal to 1 like this. I can divide both sides by 3. Then I'm left with sine x. So sine x here is equal to 1 over 3. I'm sure we agree. Then x is equal to arcsine of what? Of a third. What is arcsine of a third from a calculator?
$19.5.
19.5. Now they will give you a range and say your range is 0 is degrees less than or equal to x less than or equal to 360. So that will not only be the correct answer. Can you see this? Because I will apply this now. 19.5 is in the first quadrant. Can you see? And it's positive. So it means it's 19.5 here. I'm sure you now see that. And it's also 19.5 there. Clear?
Yes.
So it means the other angle that I want here is 180 minus, what's 180 minus 19.5?
160.5.
Yes. Then those are the two angles. Clear now? Hope it makes sense.
Yes.
Now, let's talk about the negatives whilst we are still there. Quickly talk about the negative here. Then we will apply the same for cos. Now, if now we have the graph of what? No, we want to talk about the negative. Sorry, I had closed this. So we said positive here, positive, negative, negative. And you can tell from this graph. Now, if I have sine like this, I want you to pay attention. Sine 215 degrees. So this is 90 degrees. Are we agreeing? This is 90 degrees, 180. Yeah? So what is 180 minus 215? 215 minus 180, what are we left with?
35.
35. So it means I have 35 here. I'm sure you see what I'm going to do there. 35 degrees, remember this is 215. Huh? It's also equal to, because it's negative in here, I can also put 35 like this. Clear? So it's also equal to 360 minus 35. What do you get? $360 minus 35. What do you get?
325.
325. Like this. So if I was given a question which was like this, 4 sine x is equal to minus 3, then I want to solve it. Huh? So I know that sine x is equal to minus 3 over 4. I'm now looking at the quadrants like this. Then x is equal to arcsine. So what's arcsine in your calculator? Of negative 3 over 4. Arcsine of negative 3 over 4.
Negative 48.6.
Negative 48.6. So there, do you know what you do now?
Yes.
Negative, I'm sure you have an idea, because it's negative in the third quadrant and fourth quadrant. So it simply means 48.6 here. Clear? Then 48.6. So the first angle that is within the range of 0 to 360 will be this 180 plus 48.6. Huh? Clear?
Yeah.
Which is 228. Clear? So sine 228.6 degrees, or 360 minus that. Clear now?
Yes.
So before we go to the cost graph, the other thing that I saw in the gene paper, thing that I saw that there is as mentioned in your marking scheme there, is you need to think of this here. What if we say y is equal to 2 sine x, or y is equal to 3 sine x. So what I'm going to do is I'm going to start with the original graph of sine x, then use the same thing here. And we want to see what happens. So 0, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Then we're going to have 1, negative 1, positive 1. We said 0 there, 1, 0, negative 1, 0 for the original graph. Huh? So this is the graph of y is equal to sine x. Okay, clear? So this is the x-axis, y-axis. Now let's think of now this 2. So if I say 2 sine 0, if sine 0 is 0, it remains at 0. Can you see that? Sine 90, I'm sure I guess, sine 90 is 1. What is 1 times 2? Is 2. So it means the amplitude goes to what? To 2. Then there at 0, it remains 0, because 2 times 0 is 0. At 1 there, it goes to all the way to negative what? Negative 2. So the 3 one will go to negative 3 there. I'm sure he guesses. So you see what will happen? That's the graph here. Clear now?
Yes.
The wavelength does not change. It's the amplitude that changes. Clear? Now, what if now it is y is equal to minus 2 sine 2? Want to see what happens to this? Negative now. So I'm sure you can see it's a reflection. Huh? Now the 0 does not change, because negative times 0 is 0. But there where it's sine 90 is 1 times negative 2 is minus 2. Can you see that? Then this one remains there. Then this sine 27 is minus 1. Minus 1 times minus 2 is positive 1. 2 like this.
2.
Can you see what has happened? This graph is a reflection along the what? Along the x-axis. Clear? It's a reflection. Makes sense now?
Yeah.
Okay. Now, let's look at the graph of cos theta and the properties. To 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Clear? Now, what is cos 0? Find out from your calculator. What is cos 0?
1.
Cos 0 is 1. What is cos 90? Should be 0.
0.
Cos 180, negative 1. 270, 0. 361. So you have a graph like this, which is out of phase with the sine graph by 90 degrees. Okay, like this. Clear?
Yeah.
Clear, clear, clear. That's the graph of y is equal to cos theta. Now, positive way, first quadrant and last quadrant. Clear? So it's positive in the first and positive in the last, fourth, huh? Clear? A negative here, negative here. Such that if I say cos 15 degrees, as an example, cos 15 degrees, first quadrant, also positive in the last quadrant. So it means it's the same as 360 minus 15 degrees. Can we get that? What is 360 minus 15? 340 cos, that 45?
Yeah.
345, yes. Check from your calculator, they should be the same. Cos 345 and cos 15. Huh? Clear now?
Yes.
Makes sense? So it means we can also solve equations of positives. Huh? For example, let's say 2 cos x is equal to 1. Divide both sides by 2, cos x is equal to half. Huh? Are we agreeing? Then x is equal to arc cos. What's arc cos of half? Should be 60 in your 60 degrees in the calculator.
60, yeah.
Yes. So 60 degrees here. Where is the other 60 degrees in the last?
Last.
Well, it's positive here. 60. So it's 300 degrees, huh? Like this. So the answer is 60 degrees or 300 degrees, depending on the range that they've given you. If they say a range of 0 less than or to up to 360, then it's that. But if they'd said the range of 0 up to 180, then this is above 180 altogether. To be only one solution. Exactly?
Yes.
Okay. Making sense?
Yes.
I hope we are making sense here. Now, let's do another one for the sake of, so that we just make sure we're on the same page here. So if we say, y is equal to, let's say, 5 cos x is equal to 3 like this. Sorry, cos here. So, sorry, 5 cos x, not y. Then cos x is equal to 3 over 5, which is a positive, huh? First quadrant. Then x is equal to arc cos of 3 over 5. What do you get? 53.1 degrees, clear?
Yes.
53.1 degrees or 53.1 degree, huh? Which is all the way from that, sorry. 360 minus, what do you get? So it's 53.1 degrees, or what's 360 minus 53.1?
306.
Yes, 0.9 degrees. Clear?
Yes.
Now let's have another example where we deal with a negative. If we say 3 cos x is equal to minus 1. So it means cos x is equal to minus a third. Then x is equal to arc cos of minus a third.
$109.5.
109.5, which is fine. Second quadrant, which is negative. Huh? So 109.5. Look at this. This is 90 degrees plus 105. What do you get? So sorry, 90 degrees. Then remember, we need to do 109.5. So it's something like this. Huh? 109. What's 109.5 from 180?
71.
You said 109.5. How can it be 7?
Oh, sorry.
70.5,
Yeah.
like 70.5. Where else is cost? We said cost is positive in the first. Look at this. First, you can tell from the graph if you have forgotten. First and last quadrant. So it's also there in this quadrant here. Clear now? So we also do another 70 point what? 0.5, huh?
Yes.
Which means it's 180 plus 70.5. What's 180 plus 70.5? 250.5. And if you do cos 250.5, you see that you get an answer very close to, because you have rounded, huh? So it won't be exactly 130. All right, together. Can you see that it's very close to 13333, but because we rounded, clear now?
Yes.
Makes sense.
Yes.
Or it doesn't make sense.
It makes sense.
Any questions so far? No questions.
No questions.
Okay, take a 10 minutes break, then we just look at some questions to deal with everything we've been doing. I'll stop the recording. The recording was for the lecture. Okay.